Good day everyone. Today we're going to take a look at paragraph 6.2 and it's all about diagrams. So first we did quite some calculations with percentages and now we're going to use that knowledge on diagrams because I think most calculations in this paragraph won't be that difficult, but you must be able to calculate using percentages to do the exercises. And in this video, I'm first going to take a look at theory A and B, and theory C about ternary diagrams I will do in a separate video. Let's start with start. We're going to take a look at what the book calls theory A, bar charts and line graphs. And there are quite some terms in red here, which I've translated in Dutch for you guys. So what they say is, collecting numerical data is part of descriptive statistics. Well, in Dutch that's going to be zogenaamde beschrijvende statistiek. Je beschrijft zeg maar data op zo'n manier en je geeft het weer zodat je kan zien waar je het over hebt. En dat is eigenlijk een manier van beschrijven. And we have quite some different types of diagrams that we can use for that, or charts sometimes they call them too in English. For example, the first one we're going to talk about, I have drawn one to the left right here, is called in English a pictogram, right, in English. In Dutch you can call it a pictogram, but if you go take a look at Dutch books they often just call it een beelddiagram, omdat een bepaald beeld geeft. In this case, right, a whole apple is 10 apples and a half apple is 5 apples. So now you can take a look at how many apples you have sold in January, February, March, April. And if you want to, you can continue that, so on, so on. So that's what they call a pictogram. However, it's very time consuming to make those things. So mathematicians, or some other people I really don't know, came up with something different, what they call a bar chart. In Nederlands een staafdiagram. An example of that you can see to the right here. And there are quite some rules that you have to use and that you should know if we're talking about bar charts. First of all, if you're going to draw this, or if you're going to take a look at it, you will see that they always contain, and that's point 2 here, they always are labeled. It means that it should be clear what the bars depict. In this case, well, the B is for Belgium, the G is for Greece, Great Britain, Austria, etc. And here on the vertical axis you see the number of long holidays in times 100,000. So if we're going to take a look at Belgium, it stops at 8, right? So that means that in Belgium there were 800,000, 8 times 100,000 long holidays. And that immediately answers point A, or take a look at point A for a moment. The length of the bars represent the amount. In this case 8 is going to be 800,000. For Greeks it's going to be 600,000. Great Britain is in between, 500,000, etc. And then there is one small point that is discussed right here. The bars are separate. And that's quite important because in a couple of paragraphs we will also see a different kind of chart which looks a lot like this, when in that chart the bars are not separated. So remember, in bar charts the bars are always separate. And you can do some calculation that, right? You can take a look at the exercises that you have to do, but I think most of them are quite clear. So first I'm going to take a look at other kinds of diagrams and charts. And another one that they're going to explain to you guys is line charts, right? Een lijndiagram, logisch, ziet eruit als een lijn, right? So they made a great, they gave you an example and they're going to describe what you are looking at. So here we're drawing a line chart for the number of long holidays to Great Britain, right? Also remember, it is labeled correctly. If you want to draw one yourself, always label them clearly. So mark the years on the horizontal axis, the number of long holidays on the vertical axis. Then if you have your statistics, right, so they give you, it's 490,000 in 2002, you're going to place a point here, 460 in 2003, and then 420 in 2004. First you're going to draw the points into your graph. And afterwards, after you've placed these dots, or plotted the dots, you can use a line segment, use your protractor to draw the lines, and then you've connected the dots, right? Just as in your childhood. To prevent line charts from becoming too tall, you can adjust the scale along the vertical axis, right? You decide which numbers you place here. So try to find numbers that are going to correspond to a clear diagram or chart in this case. And also sometimes you can use a so-called tearline, of een scheurlijn in het Nederlands, right? Because if there in your data there aren't any long holidays that are less than 350,000, it's quite absurd to first going to draw 0 to 20, 40, 60, 80, etc. Then your chart is going to be off the roofs. It will be very long. So what they've done, they've included a tear line. That indicates that, right, we know that 0 is here, but this part of the chart doesn't say us anything, doesn't say anything to us. It's not necessary. So we leave it at that, and we're going to include a tear line, right? And there is no tear line on the horizontal axis, so it's just 2001, 2002, etc. And again, they're going to ask you to draw some of those yourself. So that includes line charts, bar charts, and pictograms. The third one the fourth one I would like to talk about, we're going quickly today, is so-called pie charts. In het Nederlands bekend als cirkeldiagrammen. Heel soms noemen ze het ook wel taartdiagrammen, de letterlijke vertaling, maar de meeste bronnen zullen het gewoon een cirkeldiagram noemen. Als we het over het taartdiagram hebben, het is niet fout, maar het wordt minder gebruikt in het Nederlands. Take a look at this pie chart. I think most of you have already saw those kinds of diagrams, just in, well, maybe in the paper or some exercises at other lectures. The circle is divided in so-called sectors. In this case, we have 4 sectors, right? And the sectors correspond to the data that they give you. In this case, less than 25 euros between certain data and more. And the purple sector doesn't give you the percentage, but we can always calculate it if you want to, right? Because the whole circle is 100%. It's all of it. So if we're going to do 100 minus 17 minus 39 minus 32, we're going to end up with, let's see, 12, I think, if I've done the calculations correctly. So there could be a 12% right here. Sometimes they want you to calculate that too. Also remember that in a circle, or the circle itself, is all the angles add up to 360 degrees. So what they want you to do sometimes is, well, calculate how many degrees this 70% corresponds to, or this 39%, 32, and the 12. And together they form 360 degrees. So they give you an example there of 35%, and I give you another one of 32%. 32%, remember, the multiplication factor is 0.32. So 0.32 of 360 degrees leaves us with 115.2 degrees. But Mr. Opstraat, why do we want to calculate in degrees when we're talking about percentages? Well, sometimes they give you some information or some data, and it will ask you to draw a circle diagram or a pie diagram. Sorry, please do not call it a circle diagram. Pie charts. Pie charts. So, for example, here they give you some information about students in class 2F. 90 of them have cycled to school, 7 has taken a bus, 4 has walked to school. So, in total, there are 30 students. So, if you want to know how many of what angle corresponds to the bus sector of the pie, it's going to be those 7 divided by the total times 360 degrees, because we're talking about the whole circle. It's giving you 84 degrees. And you can do that for the other 2 as well. And together they add up to 100% again. And if you want to draw one right here, Start by calculating the angles of the sectors. You should be able to do that. Draw a circle and a vertical radius inside of a circle. If you don't know what they mean with that, I'll try to show you guys. Switch to pen. You start by drawing one vertical radius, right? That's your starting point. So from here on out, you're going to measure 84 degrees and then you draw this line, right? But done straight. I'm doing this freeform. So this is going to be your first sector, and that sector is 84 degrees wide. And you can also calculate which percentage it is if you want to, right? If they don't ask you to do that, you can do it this way, right? And you can do that for all the angles. Color them. Add a key. A key is a legenda, right? So we know what we're talking about. And add a title. How does class 2F get to school in this case? Right, I'm going to switch back to my pointer. I'm going to scribble on screen. Right. So for example, here they want you to represent the data in a pie chart. And remember, you do not know this part, right? So what you're going to do first is add up all the T. This is called T, so calculating all the tons of T together. So our total is 12,500 degrees, not degrees, ton of T. And now we can calculate the degrees that correspond with each kind of T. So black tea is 7,000 ton. So 7,000 divided by 12,500 times 360. And we can do that for all the T that is given to us. Right? So in the end, we have 4 degrees given with each T. And after that, you can start drawing the diagram. So again, first start by drawing the vertical line. In this case, black T corresponds to more than 180 degrees. So you could first take a look at 180 and then add 22, right? If you find it difficult to remember. Or you can just start by first drawing the other 3 sectors, and what you're left with is going to be the 202 degrees, right? That's also a nice way to do it. You find it difficult to draw sectors which are higher than 180 degrees. So try to do this for yourself. There are not that many exercises with diagrams, but the big chance that one of this kind of diagrams is going to end up in the test paper. So try your best, please. And in the next video, I will take a look at ternary diagrams. And I think those are the most difficult of the diagrams.